Welcome to Module 1. I'm going to walk through some of the math or statistical problems that you're going to be asked to complete this week when you're doing your exercise for descriptive statistics. So first we're asked to look at this partial relative distribution, and it wants us to determine what is the relative frequency of class D. Well, these total of A, B, C, and D must equal 1 because we're looking at these percentages. So that would be 100%. So to find D, we can simply say 1 minus the sum of these numbers, and we get 0.37. So the relative frequency of class D is 0.37. Then it says, suppose that the sample size is 300. What would the frequency be of class D? Well, if we have 300 and we know that class D is 37%, we just take 300 times 0.37 and we have 111 individuals in class D. Then we're asked to show the frequency distribution for all of these. Well, we know D is 11 already. So A is going to be, 111. A is going to be equals 300 times 0.22. And B is going to be 300 times 0.18. And C is going to be 300 times 0.23. And we can check our math here by just doing auto sum, and we got our 300. So sample size is 300. So then it says show the percent frequency distribution. So to do that, we are going to say, and it's basically going to be these numbers times 100, or we could do it the long way and say, well, we could just do the opposite of what we just did and say 66 divided by 300 equals 0.22, but we've got to multiply that by 100 and we get 22. Which, when we have a simple case where we're doing 100%, we could just eyeball it and we could move our decimal over. But you might run into a situation where it might be a little more complicated than that, so you can just do the divisions, do it by division. So I'm just going to say it's 22%, 18%, 23%, and 37%. So this should equal 100, and it does. You're going to see another kind of a problem where this is a word problem. It says the owner of an automobile repair shop studied the waiting times for customers who arrived at the shop for an oil change. The following data with waiting times in minutes were collected over a 1-month period. And here's the data. Now, you read about in your book doing, finding how many, maybe you might, it says develop a frequency distribution using these classes. And in your book, you read about doing count if, where you would say, okay, here's how many 0, here's how many 1, here's how many 2, here's how many 3, here's how many 4. But in this case, they want us to group them together. Get rid of that. So what we're going to have to do before we can determine our frequency is we have to create what is called bins, which you would have read about in chapter 2. And in our bins, we have to create our bins. So if we want to know how many are in the class 0 to 4, our bin is always going to be the highest value in that bin. So that's going to be 4. So in the 5 to 9 range, it's going to be 9, 14, 19, and 24. Now to find our frequency, we're going to go to Formulas, Insert Function, you can type in frequency, it'll pop up. Now our data array is going to be here, or you could just type in the cells. And our bin array is what we just created. See, we just created our bins. So we say, okay, and it automatically filled them all in for us and totaled us at 20. And so we know that there are 20 total in this data set. So if we say 1, 2, 3, 4, 5 times 4 is 20, so we know that is correct. Then we're asked to develop a relative frequency distribution using those classes. So we know that in class 0 to 4 there are 6, but there's a total of 20. So we would say equals 6 divided by 20. So there's 0.30. In this one, we would say equals 4 divided by 20 all the way down. So then we have 5 divided by 20, which is 25. Then we have the 15 to 19, which is 4 divided by 20. Then the last one is 1 equals 1 divided by 20. Then we can total these up to make sure that we are accurate and they equal 1, and so we know that is correct. Then we're asked to develop a cumulative frequency distribution. Okay, so first we look at the 0 to 4. The frequency is up here, which we have, so we could say it's 60. I'm sorry, no, it's just 6, right? The number's just 6. So the first one is 6. So then the next one would be 6 plus 4 since it's cumulative. So we know that 10. So what we're saying here is that anyone who waited 9 minutes or less. So we have to add in that 6. The next number was 5. So we add 5 to the 10, we have 15. Then we have 4, which is 19. And then there was 1 in the last one, which we know we should be at 20. And it wants us to do the same thing with the relative frequency. So we have 0.3, so that's 0.5, right? 3 plus 2. And then, so then to add another 0.25 would be 0.75. And then to add another 0.5, oops, I missed one, didn't I? Okay, 30 and 20 is 50 plus 25. Oh, okay, yeah. Then this one is another 20. And I can always say, if I don't want to get my math all mixed up, I could do it that way. Then another 5, which gives us 1 for 100%. So we're asked what proportion of customers needing an oil change waited 9 minutes or less. Well, I kind of gave you that, right? So 9 minutes or less is going to be 50%. Now we're asked to consider some central tendency numbers. So they want us to calculate the mean, the median, and the mode from this set of data. Well, first thing I want to do is I want to get my data all in one cell so that I can easily do formulas. So first they want us to tell a mean. Well, a mean in Excel is called average. My array is going to be here. I tell it okay. My mean, I will round that up to 2 digits. I want to do all these at 2 digits. So let me go ahead and just do that real quick. So format cells, number 2 digits. Okay. Then my median is going to be median. I have my same data array. Tell it okay. It's 55. And then my mode is going to be mode. My same data array. Tell it okay. My mode is 50. Now this next question a lot of people struggle with, but it's not complicated if we refer back to the textbook. So the question says the results of a national survey showed that on average adults sleep 7.2 hours per night. Suppose that the standard deviation is 1.6 hours and that the number of hours of sleep follows a bell-shaped distribution, which you read about in Chapter 2. So it says use the empirical rule to calculate the percentage of individuals who sleeps between 4 and 10 hours per day. So in Chapter 2, the empirical rule says that approximately 68% of the data will be 1 standard deviation. So let's break this down and say 68% is 1 standard deviation. And then it says approximately 95% will be within 2 standard deviations. So 95%, 2 standard deviations. And then it says almost all the data will be within 3 standard deviations, and remember that can be positive or negative values. So almost all 3 standard deviations. Okay, so now considering that, so let's see. My mean is 7.2 and my standard deviation is 1.6. So I could say minimum and maximum. So if I wanted to look at this and say, okay, so the minimum value on 68% would be the mean minus the standard deviation. And then in this one, it would be the mean plus the standard deviation. Well, that isn't quite right because we're looking for between 4 and 10.4. So let's try 2 standard deviations equals the mean minus 2. Oops, back up. Let me look. Okay, hold on. Equals the mean minus 2 times the standard deviation. And this will equal the mean plus 2 times the standard deviation. And it's 10.4. So because I got this value, now I know the answer is 95%. because of the empirical rule says I was between. And you will see this will pop up again in future modules. So this is definitely something you want to commit to memory because it will reappear. So the percentage is 95. Then we're asked, what is the Z value for an adult who sleeps 8 hours per night? Okay, well, let's see. 8 hours per night. The way we're going to do this is equals 8 hours per night minus the mean. All of that divided by the standard deviation, and I'm going to give that 2 digits. Your assignment will tell you how many digits, how many decimal points. It'll usually say 2 or 4. So the answer is 50.50. And then it asks us the same thing for a person who only sleeps 6 hours per night. But we'll do the same formula. Equals 6 minus the mean divided by the standard deviation. And that's negative. So anytime you have a negative, you want to make sure, unless it asks you to give the absolute value, which is where it doesn't matter if it's negative or positive, you always report it positive. But unless it asks you that, always make sure that you include that negative, because if not, then there's a big difference between negative 0.75 and 0.75. So that concludes the math on the assignments that you will have in Module 1. And if you need any additional help, let me know. I'm going to, you're going to find this spreadsheet with my answers filled in on the module, because you're going to have different values. You'll have the same questions, but you will have different values. So I'm going to leave this up there just so you can have a refresher of what, if I did any formulas like that, so you can look back and have a reference on what did she do in that cell. So good luck, everyone.